So what we're going to do now is model something called a magnetic lens, and what we're essentially going to do is compute the trajectory of electrons through a magnetic field. And the magnetic field is generated via a coil assembly. So current flows through a coil which sets up a magnetic field, and then we're going to study how the magnetic field interacts with the electron trajectories. So I'm going to start by opening an existing model. And this existing model has already set up the coil assembly and computed the magnetic fields. So the magnetic fields are computed using magnetic fields interface in this study. And if we look in the graphics window here, we can see the green arrows represent the magnetic field lines. The orange domain here represents the coil, and the red arrows represent the electric current flowing through the coil. So what we're going to do now is use this magnetic field and compute electron trajectories through this coil assembly and out into free space here. So I'm going to start by actually adding some parameters to the model. There are some parameters already defined here when the magnetic fields were being computed, the applied current and the number of turns in the coil. The first thing I'm going to do is specify the initial energy for the particles, which in this case I want to be 500 electron volts. So from this energy I can very trivially compute the initial particle velocity, which should be the square root of twice this energy divided by the particle mass. And the particle mass I'm going to define as this built-in physical constant in Kامسول called me_const. So within Kامsól there are a list of predefined physical constants, and these are available in the documentation. So me_const is basically just a numeric value which corresponds to the mass of electrons, which is 9.1 times 10 to the minus 31 kilograms. So we can see that Kάμsól has computed the initial velocity value to be roughly 1.3 times 10 to the 7 meters per second. Okay, so I'm going to use these parameters later in the model. Now I want to add the physics to the model. So if I right click on Model 1 and choose Add Physics, under the AC/DC area we can see there's a charged particle tracing interface, and this is the one I'm going to want to use. So if I add the selected physics, we can see that the dependent variable is going to be the particle position vector, which is called q. So if I click Next, I want to select the study type, and when computing particle trajectories, the study type is always time dependent. And since the magnetic fields have already been pre-computed, I don't want to solve for them in the same study, so I can deselect them. And then if I click this racing flag, then that finishes adding the physics and a new study to the model. So the first thing we need to do is decide which domains we want to compute the particle trajectories in. And by default, all domains are selected. Now, I don't want to compute the particle trajectories in the coil, because obviously the particles can't go through the coil. I only want to compute particle trajectories in this air domain surrounding the coil. So I'm just simply going to select that domain only, left click and right click to confirm, and we see that domain selection 1 is set. If our particles are traveling close to the speed of light, then we may want to turn on the relativistic correction. That's not necessary in this case. If you have secondary particles in the model, you may want to tailor this number depending on how many secondary particles you expect to have. In this model I'm not going to have any, so I'm just actually going to set this to 0. So if I click on the particle properties node, we can see I need to enter two quantities, the particle mass, which again we're going to use this built-in physical constant within Kάμsól, me_const, and also a charge number. And this default is -1, which again corresponds to the electron, so I don't need to change any of the settings here. What I do need to do is add a force to the model. So if I right click on charged particle tracing, I can see there are a variety of predefined forces available to me: electric force, collisional forces, particle-particle interactions. In this case, I want to use the magnetic force. So I choose that, and then I want to choose just the air domain, so that's domain number 1. And then I need to decide on something to use for the magnetic flux density. And this has already been computed in this magnetic fields interface, which is denoted by the tag MF. So if I click on this combo box here, I can choose this pre-computed magnetic flux density here by matching that to the tag, which is denoted by MF in this case. So now Comsol will know to use the value of the magnetic fields computed by this interface when computing the particle trajectories. There's an option here which I can use to smooth the magnetic field and make it more accurate when computing the trajectories, so often it's a good idea to check this checkbox. So now the forces I want to apply have been set. Now I just need to tell Comsol how to release the particles. So if I again right click on charged particle tracing, I can specify release of particles on the domain level. I can release them from a grid. In this case, I want to release them from a boundary, so I'm going to choose this inlet feature. And I want to release them from this boundary here, and we're going to fire them through this coil assembly in the Z direction and see how the coil assembly and magnetic field focuses the electrons. There are lots of different ways of specifying the initial position of the particles. I'm going to actually choose projected plane grid in this case, which essentially means uniformly distribute the particles over the selected boundary. In this case, I'm going to do 3,000 particles. I also need to specify an initial velocity, and we did this in parameters before. Our parameter was v0. So this is going to be our initial particle velocity, and it's only going to have a z component. So the physics in the model is now completely specified. I now need to specify some study settings. And the particles with an initial velocity of around 10 to the 7 meters a second are going to travel through this modeling domain extremely quickly. So in the times range, I want my maximum time to be only 5 nanoseconds. And we can output, say, let's say 50 time steps. So I'm almost ready to solve. I just need to tell Comsol which study to use for the magnetic field when it's computing the magnetic force. So under value of dependent variables here, for the variables we're not solving for, which is the variables in the magnetic fields interface, we can select that should come from study 1. So this is an important step when setting up the model. You have to tell Comsol which study to use for the computed magnetic flux density. So now the model is completely ready to be solved. I just click on study 2 and select compute, and the problem begins to solve.